Nafty, nafty.
So, the FreeBSD project is a community-driven project. The active developers do elect every 2 years a new core team of 9 people responsible for deciding the project overall goals and directions, as well as validating new committers' proposals and work on the project overall bylaws. The FreeBSD Foundation is a 501 US-based non-profit organization dedicated to supporting and promoting the FreeBSD project and community worldwide. Funding comes from individual and corporate donation and is used to fund and manage the project, fund conferences, developer summits, provide travel grants for developers. That's how a bunch of people are heading here. The foundation purchases the hardware to improve and maintain the FreeBSD infrastructure and publishes FreeBSD white paper and marketing material to promote, educate, advocate for the FreeBSD project. The foundation also represents the project in executing contracts, license agreements, and other legal arrangements that require a recognized legal entity.
It's very serious.
Yeah.
To quote its website, the OpenBSD Foundation is a Canadian not-for-profit corporation which exists to support OpenBSD and the related projects such as OpenSSH, OpenBGPD, NTPD, etc., EuroSSL. It is a fundraising entity only. It does not own any copyright over the code, even for sponsored work. It's responsible also for funding the day-to-day needs of the project, the hackathon, etc., and works solely through donations from users and company. It has no influence whatsoever on the project itself. Also, the country of origin is kind of important. While it may not seem like it at first, it actually is when it concerns the operating system. OpenBSD being based in Canada means that we are not subject to the US crypto export regulation at all. Of course, as a consequence, it was illegal to re-export OpenBSD from the USA early on, and no US citizens were allowed to work on crypto of the project.
So remember, people, it is very important to donate to both foundations.
Yes. So now let's just jump straight into a very controversial subject. Baptiste.
Yeah.
What's the deal about that libexo thing?
Have you tried to parse the netstat output with scripting languages? Well, having a programmatically parsable output is very handy to write software on top of FreeBSD quite quickly, and libexo is very useful for that. It provides the ability for the program to output some JSON or XML output.
Well, even if I agree with you, does tools like LS really need to have libexo output? I mean, that looks like over-engineering and speak. All scripting languages provide an API to be able to deal with file systems, so I don't see the relevance here.
Well, to be honest on that one, I had to search hard to find a usefulness, but I found one. So, how do you with scripting language deal with some BXD extensions like ch flags? All the languages are not aware of this, so you can have it through the libexo.
Yeah, I'm kind of torn about this. It's not because one can implement something that one should. LS dash comma? Seriously?
Honestly, I have no argument about that one. So the fun history behind this one is we discovered it at EuroBSDcon last year on someone else's talk, and everyone in the audience thought it was a typo on the slides. But it is actually a thing, and I have no argument for this one.
Well, see, from my perspective, this all looks very over-engineered. Yes. So I mean, even just for the GL management. GL administration, for example, we almost have like 10 plus third-party tools to handle that. Why? I mean, why don't you have one good tool instead of 10 written by different people and from different quality? There is a similarly huge list of tools for controlling different aspects of ZFS and all. Some in base, some not. sorry for mentioning this, but 3 firewalls, I mean, it can be very confusing to know which one to use and whether you can mix them or not. Or, I mean, when you're new to FreeBSD, it's all very confusing. So from an outsider, I would say that IPFW should be the native firewall. I mean, it was written by FreeBSD for FreeBSD. So why keep IP filter and PF, which as far as I know has not even been synced with upstream for years?
So, I have multiple things to say there. So for jail, the provided default tools in base system are, in my opinion, good enough to manage them. They are flexible, they are nice, they are simple to use, and all external tools are mostly to provide some extra features like automated provisioning, which I don't think belong to base because they can evolve faster, and if they are available in the repository, it's way easier to have updated version and remember that a branch will live for something like 5 years. So considering ZFS, the only one I have in mind is BE@ADM, which could be missing in the base system, which would allow to have multiple boot environments. This one will, yes, end up in the base system one day, if not yet. I haven't checked for a while what happened recently in that, because it's useful, but it's planned to. Considering the firewalls, yeah, true. IPFW has been developed by and for FreeBSD, but as long as we have people that are willing to actively maintaining older firewalls, yeah, there is no issue with that. So regarding PF, exactly. So regarding PF, it's true it hasn't been synced for a couple of years, but it's still actively maintained, beside what you're saying. And it has features that are not yet available on OpenBSD, which makes syncing difficult, like we have SMP support, VNet is another example. So remember, it's all, in our case, about flexibility, and yes, sometimes flexibility has a price. We can have a multiple version for something, but it's for users.
Well, in OpenBSD, we like simplicity. I agree that we may miss a few features here and there sometimes, but ready to accept it if it keeps it clean, simple, and self-contained. It is simply unsustainable to keep accommodating choices all the time. And in general, complexity is the worst enemy of security, which is one of our primary goals.
Well, flexibility does not mean complexity. We also like simplicity in our case.
Bye-bye. Let's not talk about that. No one's interested anyway, so. Baptiste, come on. So, good. Okay, I guess we can say a few words about the file system, but you go first.
Okay, so in FreeBSD we support multiple file systems. So the native one being the original UFS that had evolved in the time. So it now support modern features like journaling, soft updates, stream, etc. We also, of course, support very modern file systems such as ZFS as a first-class citizen. Our file system support is extended to some random other file system like MS-DOS file system, X2, 3, and 4 without journaling, NANDFS, and more. What about you?
Well, on OpenBSD, we're still stuck with the traditional BSD file system, UFS. That said, it has been extremely stable for us. At least for me, running OpenBSD in production since 15 plus years, I've never lost a file. We obviously also support like regular stuff like NFS, only version 2 and 3, because version 4 is very light, and we would need some stuff that we don't want in base, like GSS API. Our auto mounter is still AMD from 4.4 BSD. Well, it's not very efficient, but it gets the job done. I, for one, would welcome a more modern implementation. Regarding Internet SCSI, we have a native iSCSI initiator implementation. It's called iSCSI-D. I would not argue that file system is not really where we shine. We have no journal. We do have soft updates, but we still have some bugs in that code path. Like the system could panic if there is a vulnerable I/O failure. So that's why standard OpenBSD installation does not come with a soft update on any device.
Well, you really still have bugs in soft update nowadays?
Yeah, but you guys have curves. It's just too easy. It's hard to compete.
So on FreeBSD, under the hood, we have the geom layer, which is a powerful layer that provides us support for multipass through G multipass, encryption, GLE, GBDE, mirroring, Gmirror, network transport with Ggates. Also, it allows to fake hardware errors and things like that with GNOP. Very useful to test. We have a wonderful support for iSCSI targets with the CTLD, with the CAM control layer. It also includes high availability support, which is very nice. We have iSCSI and initiator for iSCSIs. On network file system, we have very good support for NFS, all version, server and client. Even PNFS support is coming very soon. We provide NATI tools to deal with most of the storage devices. It includes SAS devices with SAS util. Also, we can talk natively to SAS cards using native tools, not having to use blobs from LSI and other providers. As a client of storage, we also use the traditional AMD if we need to, but recently we have a new shiny AutoFS that happened. And that's only speaking about the user-facing utilities.
But in general, I do agree that your geom stuff is generally a better solution, maybe except with regard to multipath, which we do at the SCSI layer with MPath. So that doesn't require any manual configuration. You just plug in capable hardware and it figures it out. Regarding ZFS, which you mentioned, it's really a kitchen sink. So is it a good thing? Is it a bad thing? Honestly, I don't have a strong opinion on the matter. So I don't know. It's truly a very nice piece of technology. There's no argument here. It comes with very nice features. However, the fact that it strongly recommends using ECC memories kind of worries me. Also, regarding RAID support on OpenBSD, it's generally in good shape, except for the RAID 5 discipline, which we still cannot boot from. So, yeah, that's a bit embarrassing, I would agree.
Yeah, about encryption, we have multiple choices on FreeBSD on top of the geom layer. So we have GLE and GBDE. Because they are on top of geom, then in main we can put any file system we want on top of it. For GLE, since recently, FreeBSD 11, we can support full disk encryption, the disk being decrypted by the bootloader using a passphrase. We also support, not in base, but developed for FreeBSD, a file system level encryption via something called PEFS, which allows to encrypt only some directories on whatever file system there is under the hood.
The way we do encryption on OpenBSD is similar to how we manage RAID devices, hardware or software. By using the biocontrol management interface utility over a software encrypting discipline virtual device. So it is already familiar to people because it's the same utility for everything. And the process is very simple. It's just one command. So obviously we'll support a full disk encryption decrypted by the bootloader using a passphrase or a key disk. That's ideal for non-interactive use, like using a USB dongle or anything.
Well, by the way, on FreeBSD, using encrypted swap is very, very easy. You just append .eli in your FS tab at your device name, and then it's automatically appending.
Well, our swap has been encrypted by default for many years without the need to do anything. So it's my opinion that swap should always be encrypted. Your SSH or PGP private key could actually end up there at some point. We do have a sys control to be able to disable swap encryption if really needed. I'm mentioning it because that is an exception to the general OpenBSD rule where security enhancements are enabled by default but can hardly be disabled. And speaking of default settings, that's really something I love about this operating system. They make sense to me at least and are very well thought of. We regularly have lengthy arguments within the project about what features should be available by default and in which way it should work by default out of the box. That's how we came up with very simple daemons. So the network-related ones are actually a good example because they solve hard problems in simple ways. I've seen a few people already understand how networking works, for example, by just reading the configuration and map page of BGP and similar.
Well, while it's true that OpenBSD is full-featured on the network side, FreeBSD is also very full-featured on that side. Back to the base system, all those daemons make your base system quite huge. Some of the tools could just be installed by ports instead of why having them in base.
We consider OpenBSD as a general-purpose operating system that provides a useful number of services out of the box. It's an important design decision because it means that all these tools are developed together. A change in the kernel or library will immediately trigger some modification to these daemons if need be. Also, anything that is part of base is audited, usually pledged, and follows our standards. The situation is totally different in ports. Also, it encourages code synchronization within the base system. That would be a totally different thing if these were part of the port stream, because things like runtime breakage may become unnoticed for some time. I'm for one very happy to have so many features in the base system, and the funny thing actually is that OpenBSD base system is still smaller than FreeBSD's.
Really?
Yes. So it's quite surprising to speak about a huge base. On one hand, you strip down the base system, removing stuff like text info and Perl, but on the other hand, you have 3 firewalls. We, on the other hand, we like to concentrate on having one way to do things.
Well, the base system for us is also a current out-of-box general-purpose system. For us, full-feature version of a given server can be installed from packages. There is no reason why it should blow the base system with a tool. If I take the example of an MTA, I mean, if you need to run an MTA, you will need to add tons, to depend on tons of external libraries. Otherwise, you won't have a full-feature one. I mean, LDAP connections, antivirus connections, anti-spam connections, everything. That's something you will get from the port tree. So let's move that to port tree. Why would I bother having a full-feature HTTP server installed on my own storage server? Of course, if a FreeBSD developer maintains that code, then it's another thing. Then it could be in. That's the reason why we ended up, for example, with 3 firewalls, which is still not a big issue in my opinion. With the exception of a couple of servers, which are closely tied to the kernel interfaces, like iSCSI target layer or NFSD, there is no need for us to provide full-featured server. And if we do provide knobs so that we can build a stripped-down version of FreeBSD if they need.
Well, I think that's actually a major difference between our operating system. We do not want to provide knobs for everything. We want to provide what we consider same default and best practices to enforce our base. Also, is it a job to the operating system to provide embedded or stripped-down editions? An OpenBSD-based installation is basically a complete forkit in itself. I mean, meaning you have everything you need to continue developing the operating system, utilities, compiler, and all. Similarly to FreeBSD, the non-BSD, ISC, NICE licensed part are isolated in the source tree, so you can easily and safely make commercial products out of OpenBSD without putting the actual responsibility of providing build nodes on us. Talking about knobs, doesn't make FreeBSD more like a toolkit to build an operating system than an actual OS?
No, not at all. FreeBSD by default is a full-feature OS, as I said. In the binary form, we only do support the plain full FreeBSD as served by the ISOs. So, but keep in mind that FreeBSD is also widely used in embedded environments or inside appliances. Both need lots of flexibility, either stripping down the side for embedded or being able to replace one feature we do provide by their own implementation for some appliances. Also, we do encourage a lot of vendors to work closely with their upstream, in that case, meaning us.
Yes. FreeBSD does encourage vendors to contribute and commit, but it wants to be like a universal operating system, like Linux, and satisfy the maximum number of people. If you look at it from a different perspective, it would also say that FreeBSD does what your employer wants, while OpenBSD does what its developer wants. Anyway.
Totally false. Anyway.
I like the fact that I can have a functional problem-solving box in no time and without the need to install any third-party packages. For instance, I don't need to install a proper shell that I can work with. I'm not talking about heavily features CSH or whatever, but being CSH as the default root shells, you guys, really?
If someone is willing to push a new feature or a new knob to improve flexibility, as long as it does not break FreeBSD direction, usability, we will accept it. It's not a problem. It gives us the flexibility we need in the base system, and it's very nice to make FreeBSD usable in every single kind of niche usage if needed. For example, making a very thin storage server that runs on RAM disk like we do in Gandhi. Which makes me think that, I see that OpenBSD does not support kernel module at all. I find this very handy for flexibility, and as I can load or unload feature on demand, or if I need it without having to rebuild the kernel or play with syscontrol tunable to be able to interact with the kernel configuration. Isn't that painful to tune your kernel on OpenBSD?
Well, that is true that we did remove support for loadable kernel modules, but we still have dynamicity thanks to our config utility. It's used to modify some part of the kernel without having to recompile it. Like device parameters that are usually hard-coded in the kernel can be changed, added, or removed. It does not allow you to inject code into the kernel, but it gives you the choice to enable or disable existing code. To give you a simple example, it's often used to disable ULPT, which is the USB printer support, to make a printer using cups and libUSB actually usable by OpenBSD.
Okay, let's virtualize a little bit this talk. On FreeBSD, we do support running Linux binaries natively via the Linux simulator, also called Linux simulation. Right now, we do support Linux i386 and AMD64 binaries. There are patches available to support Linux ARM binaries. We also do support running old FreeBSD binaries on newer releases, meaning that if one wants to create a gel to run FreeBSD 4 user on binaries, on FreeBSD 11 it works out of box. On the virtualization front, we are very well featured. We do support native virtualization via Beehive. It has many nice features. We have a NetMap interface support, VNC server support. It can run almost any operating system guest as long as it supports VirtuIO and EFI. It is also fully sandboxed via Capsicum. We also support external virtualization mechanism. We can run natively as DOM0 or DOM-U for Xen, or we also have VirtualBox in the post-tree that works on FreeBSD.
Yeah, well, having Citrix people working as developers does help having DOM0 support. That's true. But I think it boils down to the fact that you guys made the decision a long time ago to not fuck with the hardware as much as possible, but instead let the manufacturer do it, and instead concentrate on something else. On OpenBSD, the situation is a bit different. We prefer to try and convince the vendors to open the specification to let us write our own drivers. Your approach is probably more pragmatic, that's for sure, but as you probably know by now, we like to be in control of the operating system. So sure, not everything is black and white, of course, and so this is to be taken with a grain of salt, since there is a lot of cross-pollination between all of our projects, and we do use some parts of your vendor written drivers, like IX, for example.
Well, being open to vendors, in my opinion, is a pragmatic point of view and does not make us lose control of our resource at all. Actually, we have very good relationship with plenty of them. They're committers running through our usual process to recruit new developers. We review the code they submit. We even extend it sometime. It's not unusual to see some vendor committers continuing to contribute to FreeBSD way after they left the said vendor. So back in virtualization, because that's what we're speaking about, what is the situation on OpenBSD?
Well, let's start with VMM, since it's been mentioned a couple of times already. Currently, it can reliably run OpenBSD, NetBSD, some Linux distribution. I assume maybe FreeBSD by now. I haven't tried. It provides a very nice user interface with VM control. And since it's shrouded and pledged, breaking out of the VM monitor means ending up in the shroud with obviously very limited list of allowed system calls. The other virtualization technology that OpenBSD supports is Sun4V logical domains, also known as LDOM. It's hardware virtualization. That means the resources are partitioned directly at the hardware level. It's supported on a Spark v9 processor. It's a pretty secure design since there is no software hypervisor involved. The processor itself runs in hyper-privileged execution mode. So it can natively run any Spark operating system, Linux included.
Right. So we were speaking in the beginning about our project internals, but what about relationship with the external projects? In general, for FreeBSD, most upstream are happy to receive FreeBSD-related patches and integrate them, even big ones. For example, dealing and upstreaming patches to LibreOffice was a very easy process. They welcomed all of them, and they even tried to set up a CI so that they are not breaking our usage. On the GNOME front, so you probably know better as a GNOME committer yourself, we don't I don't deal with the patches myself directly. We have a good relationship with JLib maintainers who came to us to ensure that JLib is working correctly on FreeBSD, on the BSD in general, by the way. And they even set up the GNOME CI on FreeBSD to ensure that everything built as fine as possible.
Yeah, I guess we pretty much share the same experience here. While some streams are more open than other to non-Linux contributions, in general they're pretty happy to integrate our patches, and sometimes they actually learn a thing or two about portability. It is true that a few identified people within the free software community take some pleasure in bashing anything that is not GNU or Linux, but these are far from being the norm, so fortunately for the ecosystem. Sometimes upstream can also be very close. We have OpenBSD developer who are also developer at GNOME, XFCE, Mozilla, LibreOffice, etc. And it's true, with OpenBSD being the upstream for several software, which I mentioned already, OpenSSH, etc. Also, some application can be very complex to port, so it's important to be able to interact nicely with upstream, because sometimes you do need their help. And when things start crashing, well, that's when our debugging tools come into action. So I will not go into the details of such tools, which are probably similar to yours. I just mentioned that we're building the entire base system with debug symbols, and that we're thinking about doing the same for ports, or at least a few identified ports. We already do that with glib and GTK.
Yeah, so FreeBSD is pretty well served for debugging. By default, the base system, we have cat trace, trust to be able to track what an application is doing. In particular, when debugging a capsicum-ized application, it's very useful to have cat trace to tell you what are the capability an application might be missing, if any. More importantly, we now have dtrace support in the base system, which is a very powerful tool to be able to do some tracing. When building the FreeBSD kernel, for example, we build it with all the debug flags, which are converted to the CTF format and are and then they are all detraceable by default. To help debugging, we also have by default the debug flags activated when building, but we split it from the binaries so that in embedded environments you don't end up with them. LDB and GDB has been configured so that they know where to figure out the path to those debug flags. Concerning the port 3, now lots of the applications are dtrace aware. but the post tree itself is still not built with a debug flag yet. It's work in progress. The goal is to also extract the debug flags after building so that we can provide debug package so you have debug flags whenever you need it, but not when you don't need it.
Right. Okay. Well, debugging is another area that has a lot of improvement and development lately on OpenBSD. Our DDB, the kernel debugger, just got basic support for CTF. That has nothing to do with capture the flag. Once being included in two binaries, CTF, or compact compressed type format, will provide a subset of the information from dwarf, debugging sections like definitions of data type and functions used by debugging tools. We also have a CTF dump and CTF conf implementation. Thank you, MPI. And we can dynamically activate kernel profiling using dtrace-like probes. So we have the bedrock for dtrace on OpenBSD.
Which is great, and by the way, I really plan to import those BSD license version of CTF dump and CTF conf. So it looks like, guys, you are slowly getting there for tracing. So both projects now are going to have both nice debugging capabilities. That's it. Another difference between OpenBSD and FreeBSD is regarding authentication and authorization. So on FreeBSD for the authentication we do use PAM. Actually the OpenPAM implementation developed and maintained by a FreeBSD developer, which is compatible with the PAM specification. It gives us access to a lot of various external modules, even for most of them we do prefer rely on our own implementation. The nice thing is that it makes it simple to port common software that already support PAM.
Well, BSD auth is what we use on OpenBSD. It originally came from BSDI's BSDOS. One of the main differences between BSD auth and PAM is that PAM modules are basically libraries which must be loaded into the application. BSD auth modules are actually separate applications or helpers located under the user libexec auth directory and that are run as separate process from the one authenticated, which allowing them to communicate over a very simple IPC interface. That means we basically never expose the credential store to a possibly buggy software. So it matches the traditional privilege separation model that we use on OpenBSD, while still being able to provide different ways to authenticate to LDAP, kernels, YubiKey, Radius, you name it. So while PAM may be a bit more flexible and way more commonly found, so there are a lot of different authentication modules readily available. It usually requires elevated privileges to authenticate. Applications using BSD auth only need to be the auth group to be able to run the helpers. Look at your OpenSSH, for example. Most of the recent advisory you had, I mean not most, but a lot of them are PAM related.
Well, in the case of OpenSSH security advisory, maybe it's also related to the fact that the upstream, meaning you, is paying less attention for obvious reasons you just studied about the PAM code itself. But it's true that the PAM API is not simple to use and is also very error-prone. But in the OpenPAM implementation, while it's compatible with the official API, it also provides plenty of extensions through helpers that simplifies adding support for PAM in application in a less error-prone manner. Anyway, for name services, we do use NSS, which provides us a lot of flexibility as well through its modular nature. Not that our NSS API is not 100% compatible with the GNU libc one, but we also provide an NSCD daemon which can cache name services responses for users, but it is not limited to that. It can also perform the requests, which means the modules are no longer loaded into the libc, but in a dedicated daemon.
Okay, well, regarding authorization and virtual system users, we only have support for traditional YB NIST.
Oh.
Yes. OpenBSD does not use NSS, so no NSSwitch.conf. For basically the same reason it does not use PAM. We do not want dynamically loaded modules to play game in our libc or resolver. We do have support from getting users out of LDAP servers, thanks to our YPLDAP utility. Actually, I see that you guys imported it some time ago, and I'm interested why. I mean, you guys have NSS LDAP. Isn't that good enough, or is it to satisfy flexibility?
To be honest, I still wonder why we have imported this YPLDAP tool, but I mean, it doesn't hurt. And as far as I know, I got feedback from at least one university that was happy to see it happen, so that they could have a simpler steps to migrate from NIS to LDAP. So why not?
Okay. Well, so I guess that those things considered, it's pretty obvious that my BSD sucks less than yours.
Yes. I have to disagree on that one, and for me it's clear that my BSD sucks less than yours. That said, I think there are areas where we both suck equally. I mean, what is the state of your wireless drivers?
That is very true. We both suck on some aspects.
Yeah. Well, that said, this presentation was done on a free BSD laptop.
You mean you're proud of not using a Mac, or?
As much as we like to make fun of each other, we are not only sharing bad things.
No. In fact, I think that cross-pollination between our two operating systems works quite well. We actually do exchange a lot of things, and it would not make sense to list everything here. But.
Well, in my opinion, OpenBSD has an important role in the open source ecosystem. You guys are tackling very important project, which would probably have never happened otherwise. The most famous one being obviously OpenSSH. But I really like how open you are to portability for those software, given the extra amount of work it gives you. If I think of OpenSMTPD, Tmax, Mandoc, SNDIO, and many others, they are very good example of that. You are also teaching upstreams about good and secure coding practices, which is a very important thing to do.
And from where I stand, I think that FreeBSD is important in the global ecosystem. It's a real enterprise operating system, and I think it's slowly filling up the spot left by Solaris. It bundles some amazing pieces of technology, that's for sure, and in some area is still on the edge of innovation. Some very large entities obviously use it, and thank you to FreeBSD. A lot of people have been made aware of the BSD community in general. So for me, it's a very good weapon to make people aware that fringe operating systems are certainly not lagging behind Linux.
For me, FreeBSD is a wonderful operating system. It's very flexible and attractive in almost all use cases. The project is very open, and everyone from vendors to individual can have their place in the project. While there are a lot of vendors involved and that contribute to FreeBSD, the project remains completely community-driven, and individual can easily find their part in the project. I'm a good example of that. In my first 2 years, I've been able to drive into the project and made some very important modification, including being part of the direction of the project itself.
Yeah, OpenBSD is a small project, but I'm very proud when I see that in some area, a small amount of hackers can compete with a huge project like FreeBSD, and sometimes actually do deliver things ahead. I like to say that we do serious things without taking ourselves too seriously. You guys say our performance sucks, we say that your security sucks. I suppose there is some truth in both stereotypes. I see OpenBSD as a kind of incubator. and bedrock for new technologies that is not afraid to break things, a sort of a destroy to build approach. I really encourage people to try and use it as a power user or developer. Not just install it, but really try using it. I've been surprised at how many people actually have a misconception of OpenBSD, even within the BSD community itself. In my experience, besides the obvious benefits OpenBSD is known for, proactive security and all, it has been one of the easiest and best documented operating system that I've ever used. And I see its simplicity as an art form. Thank you very much.
Thank you very much all, and I think it's time for a mandatory hug, BSD hug.
I love you anyway, Baptiste.
Thank you.